Hello, everyone. I've already introduced myself, but I'm now going to talk about my research topic, which is currently playing NetHack with language models. And particularly, I know that apparently there was some discussion about this already yesterday, its potential as well as like the limitations that I found so far. So maybe to quickly reintroduce myself, who am I? I'm a PhD student at Queen Mary University. I'm part of the IGI program, which just funds my research. And if anybody wants to contact me, I have my LinkedIn in here as well as my email address. And I'm researching playtesting complex games with large language models, or how I will call them LLMs. I'm collaborating with Creative Assembly, and our goal is hopefully to playtest Total War Warhammer 3 in the future. But for now, I'm focusing on NetHack because it has a lot of similar challenges that we will also face in Total War. So why am I actually looking at large language models? I have a list of pros. Of course, the reason why I switched to language model, because I had a different researcher before, is they have a lot of knowledge about games. And of course, they can be technically used as zero-shot agents, which would be extremely valuable if you want to just apply an agent to a game and then see how well it plays. That would be quite nice without having to train anything, apart from, of course, having a search algorithm. They are powerful high-level planners, so they can just look at the game. They can give you a plan of how they want to approach the game. And then they can also really well explain their choice of why they want to do it, which, because a lot of people talk about explainability, this, of course, would be extremely interesting. And they're easily controlled by using text and result in flexible behaviors. So if we want an agent that behaves in one way or another way, we can just tell them to do it instead of having to design reward functions or anything else. And there's a huge list of cons, which I will go over in the following slides, so I will not go over it in great detail. But let's first explain what actually is NetHack. This is NetHack, and it's a roguelike that was released in 1987, and it has released a lot of updates to this date. Essentially, the goal of the game is you start on level and you need to get to level 50, which is like by going down and down and down until you reach level 50. And in between, there are a lot of branches where you can go into like a gnomish mine and then into a mine town, which distracts you, but you have to do it to eventually reach actual level 50. There are a lot of items, there are a lot of monsters, there are a lot of interactions between those items and monsters, and there are a lot of ways to actually easily die in this game. And this is exactly why I chose this game, because it's a really good testbed to see how far can I push the language models to their limits. Because there is already research out there that plays games with language models. One famous example is Voyager, that plays Minecraft using language models. But their limitations are they just apply to, for example, can you craft a pickaxe? And the reason why I would say a simple problem is crafting pickaxes in Minecraft is just dig down, find whatever resource you need, and then come back, craft it. So it's very easy to do long-term planning, but it's much more difficult to do long-term planning in games like NetHack, which is why I wanted to see, what can we push its boundaries? I have two views. We have the tile view, which is just like a nice overview of the game, and we have the ASCII view. The ASCII view is quite important because sometimes you can see that there's a menu where it asks you what you want to pick up, which you cannot see in the tile view. So later on, I will have some videos, so you might want to look at both over time. And this is the architecture that I'm currently using to actually play NetHack. It's quite straightforward if we look at it. The first inputs that I have in my prompt are just like an interaction history of what the LLM had already done in the game. So in this case, we started a new game, and then we give it the task to win the game. Then I describe the observation, which is like a list of rooms inside the game with their content, like items and their positions, what monsters are in the game currently, where are they positioned, where are they relative to you. We have like an exploration status where I tell the LM, oh, you haven't looked at this room yet, or there's a boulder that blocks your path. I give it the inventory that it has and its own stats. And finally, of course, I tell it what is the current task, which is in this case, win the game. I tell it what skills it had. For example, I use a list of handcrafted skills. In this case, for example, move to XY to tell it you can move to this position, or you can pick something up, or you can drop your items. And then I give it a response JSON that it has to output. So this entire prompt is then passed to the LLM, which gives us a response. And this response is not only the task, the next skill that it wants to execute, but like a list of thoughts that it has. So essentially, I first asked this, can you tell me what do you have currently seen in the observation? Can you then tell me what do you want to plan next? And then can you give me a text that you just want to say to the user so I can display it? Essentially, can you explain your choices? And using that, the LLM essentially has some time to think about what it wants to do next. And then I'll finally ask it, can you now tell me the next skill that you want to do? In this case, it wants to move to a position. And this is now one of the scenarios that I've designed myself. So NetHack has two game modi that I'm currently investigating. One is just playing the game full, and the other is a bunch of small scenarios that I've designed myself to just test what the LLM can do. And in this case, I asked it to, in this case, I asked the language models to, if it wouldn't be hidden, but I asked it to do a bunch of tasks. I asked it to kill a monster, which is the red blob that you can see on the screen. I asked it to pick up an item, which is the lockpick. I asked it to drink from the fountain, and I asked it to open both doors in this room. And one door is locked, so it has to use its lockpick to open the door, or it could just kick it open. But in this case, it finds a lockpick, so it decides to just use that lockpick. And the text in red is actually what the LLM is thinking, which is quite difficult to see, and it's going quite fast. But we can see that the LLM is essentially doing all the tasks one by one, going through the doors. In this case, it's now currently lock-picking the door. It got it open, so it goes to the next door, opens that one. It wasn't locked, so it just opened it. It did all the tasks that it had to do, and then it tells me as a final skill that it wants to choose, I'm done with my task. What do you want to do next? And that worked quite well. It seems to do something sensible. Of course, if we now apply it to something much more complex, in this case, this is not the, this is the actual full run. So the previous run was just a test where I have a small room with some simple challenges and it just works. So in this case, I actually asked it to win a game. So it's playing the full game with no limitations and it can do whatever it wants. And when I ran it, so this will take a while. So I've set myself some, now the problem is I technically set myself some points I can go through. Sadly, they are not visible at now, so I cannot actually move through the video, which is annoying. But I'm just going to talk about what actually happened in this run, and we're just going to run it. So essentially what happened in this run is quite interesting. We start on the first level, and the language model tries to explore the level to do something sensible. Eventually, it gets stuck in these 3 rooms because NetHack is quite difficult in the sense there are a lot of hidden doors. And there are skills that allow it to find hidden doors, and it eventually will find this hidden door. Problem is the hidden door is locked, and my skills that I've designed do not open hidden doors by themselves, but instead the language model would have to say, I'm gonna kick open that door if I want to. But it didn't do that. It tried to kick open the door once. Eventually, I hope it will happen, but because I sadly cannot show you. Yeah, which is unfortunate.
Okay, so actually, how do you model like the game engine inside? So does the language model actually kind of have somehow encoded like the action and the result, or you put like, you know, because
okay, so
you said this is this part that you design for the game, like what are possible actions and so on, but do you, how much you hinted on this part of actions that when use them, why use them? So like,
yeah, so I'm not done with, yeah. So the question that was just asked is, yeah, how much does the language model actually know about the game, on what it should do? And I told it that it's playing NetHack, so it knows roughly how to play the game. What now happened in this scenario is it found a hidden door. It tried to kick it open once, but in NetHack you need to kick open doors multiple times to finally break them open. So what happened is it kicked it open once, it didn't work, so it just went on and kept doing something else. Now, the interesting thing is what happened then over time is it has a certain set of memory until it runs out of memory, and then will forget that it tried to kick open the door. So it will keep trying to kick open the door, and eventually it managed to finally kick open the door. And then it moves on to the entire game. Eventually actually getting to, like, I think depth 4, it was roughly, like depth 4 means level 4, right? It managed to get through 4 levels, where it encountered a shopkeeper, where it could try to buy items. sadly, what then happened is the shopkeepers in this game are quite mean. They like to stand in the way of the door, like the shopkeeper is in a small room, and to get out, the shopkeeper essentially stands there until you buy something or you drop whatever you just picked up. And the language model tried to get out, but it kept bumping into the shopkeeper. And then our game asked you, do you want to attack the shopkeeper? The language model said no. But then said, oh, I want to get out. And then it attacks it again and says, no, I don't want to attack. And they just kept getting stuck in this loop, attack, move, attack, move, attack, move, attack, move. Eventually I said, okay, I have in my code some limitation. You cannot do, if you do not do something for 10 turns, I'm gonna just abort the game. And that's where the essentially this run ended. Sadly, I cannot show you everything, but some interesting things that also happened is it equipped an iron chain by its own. It just found an iron chain, then it said, oh, I want to equip this because it might give me better stats. If it were actually better stats, it never checked, but it did it on its own, which was quite interesting.
Okay, but like going to this door example, so either you set the program like there can be a case when multiple kicks are necessary, so you encode some game knowledge, or you just end up with, like you said, nearly random set because yeah, there are some random actions. I mean,
yeah, I think we can maybe discuss that at the end. I think let me quickly just go through what I've so far observed. So yeah, what we can see is I haven't named my agent yet. It's called agent name. We also have an agent called authors.
You know, we can't see it.
If you click more, click on more, and
I don't see that in my case.
you can answer the I have to speak first.
Yeah, you have
That that.
Oh, I see. Oh my God,
well,
one second. I need to fix here something.
And it's high floating with controls down there.
My bad. So we have my agent name, which is my agent. We have auto ascent, which is a handcrafted agent for the NetHack Challenge 2021. That was essentially designed to play the game very well. And we have another handcrafted agent, which was designed by me, which uses the same skills as my LLM agent, but it just has very simple rules to play the game. And what we can see is auto ascent completely obliterates the language model agent. The language model agent is a tiny bit better than the handcrafted agent, but I assume just adding some more rules would make the handcrafted agent much better than the LLM agent. So does it mean that my agent is bad? I would say not, because that's what I'm talking about, right? We found a lot of limitations. It has a lot of trouble playing games, which was to be expected. But of course, when I test it on a bunch of different scenarios, like I showed in the beginning, it can solve a lot of different tasks by just asking it to to do those tasks. And now I have a probably here because it has the ability to play games in a more creative way by just telling it that you are creative. If you ask it, you are now a creative agent, can you please explore this game? It will do something like that. But I'm saying probably because I haven't fully investigated this yet. So I'm looking into it. And of course, we haven't tested the agent yet with access to NetHack Wikipedia data, because it could make much more nuanced choices. It would actually have access to the Wikipedia. And now we can hope that LLMs get smarter either by better prompting methods or better training methods, which hopefully happens over time. So now, because this is about collaboration. Sorry? Yes, I'm currently using GPT-4 Turbo because public source LLMs are not smart enough to actually play the game in a good enough way. And GPT 3.5 also wasn't good enough to actually play the game. So I'm currently using GPT-4, which is quite expensive, sadly. But quickly, because we are about collaborating, so I want to quickly go over what I'm doing in the future. So yeah, one big limitation of this is, of course, handcrafted skills, because they not only limit what the LLM can do, but it also essentially the LLM has trouble that it doesn't really observe what is happening in the game. We just have to describe it, which might be because of a lot of issues that it has. But I know that we can also use LLMs to annotate trajectories, meaning I can ask the LLM, given this, what just happened in the game, can you describe me what happened in the game? And my current idea is, okay, if I have an LLM that can describe what happened in the game, can I maybe use that to train a reinforcement learning agent that replaces my LLM over time, hopefully. And to prove that this works, I have two examples, but I'm gonna go just to this one because it's faster, where I essentially ask an open source LLM, in this case Llama 2, 70 billion parameters, to annotate a trajectory. In this case, I manually enter some commands where the LLM explores the game. My skills explore the game. I then interrupt the skill at some point, which should be now, and I ask the LLM to annotate what just happened. And there we go. Now this is the public source LLM, so its outputs are much worse than GPT-4, but essentially it just summarized the actions that just happened and try to roughly guess what happened. It's not perfect. GPT-4 is much better in summarizing what actually happened, but it's doable in some sense. So my idea is maybe I can look into this much more, because I don't need long trajectories. I just need short trajectories that I then annotate and hopefully can use to train LLM reinforcement learning agent. And now I'm done. Sadly, I'm a little bit overboard for 15 minutes.
That's
But
fine.
do we have time for questions now? I hope. Yeah.
Yeah, thank you. Interesting thought. So it's very interesting, but like, what is the main goal with this? Is it like you believe if the language models are good, that this will be a good way playing?
So so the question is.
Showing the limitations and potential of large language models.
So yeah, the question is like, why do we? Essentially, the question is right. Why do we use language models, or why am I using them? Yeah. Essentially, I'm quite confident that language model will be a very powerful high-level planner that do the high-level planning. And then the question is, first of all, yeah, we need to still figure out how can they properly observe the games, how can they properly interact with the games. And of course, there will not still be like use cases for like search algorithms, either by LLMs that use them, as well as reinforcement learning algorithms that optimize how to interact with the game. So I expect that in the future, it would be something along the lines of we have the high-level LLM that just outputs text commands. I want to go to the fridge. I want to eat a banana. And then we have the low-level skills that actually turn these commands back into actual actions. So currently, I'm asking the LLM to choose skills, but it probably would be much wiser to just let the LLM output its text command, because that's what it can do best. Of course, it's quite tricky to do that. So yeah. Does that answer the question?
Yeah, exactly. You're basically using LLM with whether be just as capable as human to play
Yeah.
the game.
Is there like a specific type of testing that you're looking at? So it sounds to me a bit like regression testing, but you were also talking about like exploratory testing.
So what I'm testing with the LLM is right now if it can play the game well, which I've already tested, and then it's about can it follow my commands in terms of I have a list of different commands in different scenarios. How well can it interact with different game mechanics in the game? How well it can solve certain other tasks I give it. And finally, I'm currently looking at how creative is it. So this is the final test that I'm doing before I publish my paper at COG 2024, hopefully, where I essentially just ask it to be creative. So you have a bunch of items. Here's a task. You can solve the task however you like. Be as creative as possible, and then I will see, how useful is it in terms of creative computing, which is it's essentially what I've observed is if it plays games, it's not super creative, but if you ask it to be creative or it's stuck somewhere, it starts to getting creative. So it's interesting, but that's what I'm looking at. I think you were first.
So I've got a question about skills. Can you say a bit more about them? How do you use specific skills? I mean, with GPT-4, you cannot constrain the grammar, can you? So you cannot output specific things. I mean, with a local LLM, you could actually constrain the grammar. You can't output very specific commands that will be kind of very close to the game.
Yeah, so language model. So yeah, the question is like, how do I encode these skills? The thing is, language models have the tendency to hallucinate, but only if you give them a lot of freedom. The moment you tell them, this is the list of skills that you have, they rarely hallucinate. They might sometimes hallucinate, but in that case, I just ask them to do it again, which usually fixes it because I just pass it back into its own prompt. Here, this is what you did wrong. And then it knows, okay, I need to fix that. And the skills, I just described them as here. It's just a list of name of the skill, a short description of the skill, and parameters. In case of move to, it has 2 parameters, X and Y. And that works very well for GPT-4. If you use GPT 3.5, it will hallucinate completely. So it depends on the power of the LLM.
You mean with the local LLM, you can fix the grammar, so you can get it to never hallucinate.
Okay, I don't know about local LLMs where you can just fix it to grammar. I need to look at that. I haven't looked at it here. That sounds interesting.
So with this GPT-4 thing that you use, I assume it's one of these models that has been instruction fine-tuned to for all kinds of safety reasons, right? So when you wanted it to attack the shopkeeper, is that why it's refusing?
So the question is if like the language model that I've used because it's restricted by a lot of things, by like essentially political correctness, if it refused to attack a shopkeeper because of that. No, it just didn't want to attack the shopkeeper because it knows that shopkeepers and NetHack are very dangerous. They will mess with you extremely quickly. The reason I have sometimes seen that it had these issues where it was fully trained on being politically correct, where I asked it to do something in a game, like drink a potion, but it didn't find a potion. There was no potion, so it said, there's no potion, I cannot do anything, see you later. And it just finished its task. But sometimes it also just decides to explore the level, which it should do. So it really depends, but yeah, I didn't have much trouble with that.
Okay, so this is kind of that's related to the question that you said that, okay, he didn't attack the shopkeeper because he knew the shopkeeper is strong and so on. So this is not the knowledge you encoded in like kind of game knowledge for him. So like this is internal knowledge of this language model that shopkeepers in NetHacks are a strong NPCs or something like that.
Yes.
So he has such kind of knowledge, even if you didn't train it like kind of especially on the very nice idea with this NetHack wiki, right?
Yes, so it's correct. Language models do not have a lot of knowledge, including knowledge about NetHack, which they used in this case to play the game. But I also tested the scenario where I censor every mention of the word NetHack. And in that case, it actually loses its knowledge about NetHack because it thinks it's playing some game, and then it doesn't know how to play NetHack. And it still figures out things like, oh, I have a pickaxe, there's a boulder, I can mine that boulder with that pickaxe. So it still exhibits knowledge, even if it doesn't know the game.
And I also think that like it will be interesting to find this correlation, like feeding exactly with like NetHack wiki. I mean, we did similar things for text.
Yeah, I agree. Like training on a NetHack wiki would be very interesting. In this case, I was looking particularly at, I want an agent that we can just, in best case, plug into the game, which would be extremely interesting for game developers, right? Where you just have an agent, plug it into a game, and then you can ask it to do whatever it wants. So I wasn't looking at pre-training it because, that wasn't the goal of this research in this case.
Maybe not pre-training, but retrieval once it's
you can also give it access to wiki by giving it skills for searching wiki data, but that was too much work, which I couldn't finish.
So you have used it completely zero shot, right?
Sorry?
Zero shot, right? You use it like
Yes.
You just put it into game, play them.
Yes, I use it.
Have you tried doing it multiple times, like playing some level, short level, that it doesn't go over the window of the context, but playing it once and playing it again if it remembers the knowledge in the same level, and then doesn't explore that much and just goes to the goal.
Okay, so essentially letting the language model play the same level over and over again, but it keeps its context information. Yeah. I didn't test that because my context is only 500 tokens, and it's not like it will forget everything about the previous level likely after it's done with this next level, simply because the context isn't long enough. The language model I'm currently using has 228K tokens that it could accept, but it would cost me so much I would get bankrupt. So yeah.
Okay.
So I'm just as a result question, but maybe really dumb, but I was curious at the end you show moment where you could enter to the AI and asking some question on why you did something. Could you do like, for example, stop it and give him like insight that, oh, you had this example where I tried to kick the door but only once. And could you answer it and send him the message like try kicking the dog again?
So yeah, Yeah, the question would be if I can interrupt the agent and then tell it something, what it should do next. Yes, that would be easily possible where you could observe the agent and then immediately send in a new message, please try kicking open the door again. That would be very easily doable. I haven't done that, but yes, it would be possible. And it would, of course, in that case, follow whatever you tell it, because essentially, if I tell it to do something, it gets as input, the human is asking you to do something, and they will always follow what the human tells.
Yeah, you can give him an advice, but if it's bad advice, then it would say, oh no, it's a bad advice. And
Yeah, it will always do whatever you tell it. And one thing I observed is if you're very vague in terms of how you phrase things, like try to explore the first level thoroughly and then move on. It won't leave level 1. It will never leave level 1. So it's not very yeah.
And also, could you have the opposite things, which is AI commenting what you are doing? So you are playing the game, and the AI would be try to do that, try to do
yeah,
that.
that's exactly like, yeah, if I want an AI that comments what I'm doing, that's essentially the current research. The next research that I'm planning to do is where I ask the LLM to annotate trajectories, where it tells me what happened in a trajectory. So because I want to use that to train text foundation reinforcement in action.